Have you ever wondered, could time really be the beginning of everything? What if there is a past beyond space that we cannot see? Some scientists argue that the Big Bang was not just a beginning, but perhaps the last breath of another universe, or even a reverse cosmic passage. Imagine if our universe is actually being pulled toward an end, or if we have been thrown out into a completely different reality. We are now approaching an extraordinary claim that challenges the limits of reality, overturns scientific thinking, and calls into question the very concept of time. Get ready. After this video, your view of the universe may never be the same again. 1. Did time exist before the Big Bang? The concept of time exists in human perception as a linear line. We feel that it has a beginning and an end. However, the question of whether time has an absolute beginning remains one of the greatest unsolved mysteries in cosmology. The Big Bang is defined as the moment when the universe began to expand. However, whether time existed before this point is a profound question that could potentially challenge all our existing assumptions about time itself. According to many theories, time began with the Big Bang, and there was no such thing as time before it. In other words, talking about before would be meaningless. In contrast, some physicists and philosophers argue that time may have existed before the Big Bang, but that we are unable to perceive that time or the events of that period. In particular, in cyclical universe models, time is an infinite cycle, and the collapse of each universe leads to the next Big Bang. In this case, time periodically starts over with the expansion and collapse of the universe, and we can only perceive the time of our own cycle. The flow of time emerges with the expansion of the universe, and before that, there may have been a completely different structure or dimension. In quantum cosmology theories, time is not like a flowing river in the classical sense. It is more like a wave of possibilities. Here, time is a concept entangled with space, and there may be a temporal reality that existed before the Big Bang, but is beyond our perception. Understanding how time functioned before the Planck time, when the universe was very small, hot, and dense, is nearly impossible with today's laws of physics. Perhaps time emerged as we know it as the universe expanded and cooled. Ultimately, the question of whether time existed before the Big Bang reflects humanity's philosophical and scientific quest for a beginning. If there is no before time, then the universe was created with an absolute beginning, which contradicts the idea of infinity. If time has always existed, then the universe is constantly reborn in a cyclical process. In either case, the question of the beginning of time stands at the very center of the mystery of the universe and humanity's infinite curiosity. By the way, if you like my video and subscribe, that's the most effective way to support me. 2. Was there another universe before the Big Bang? One of the increasingly debated topics in the scientific world is whether there was another universe before the Big Bang. In particular, multiverse theories suggest that our universe may be just a small part of a much larger cosmos. From this perspective, the Big Bang could be a rebirth arising from the collapse, or even the death, of another universe. If this is true, the universe we live in may be composed of the remnants or energy of a previous universe. According to some theories, the trigger for the Big Bang could have been a black hole or a white hole that collapsed into another universe. In this case, there's a kind of cosmic cycle or birth-death relationship between universes, and we are merely living in the last link of this infinite chain. In such a model, each universe could have its own physical laws and conditions, which would help explain why we live in this universe. So perhaps there was another universe before ours, and the end of that universe gave birth to ours. Could traces of these ancient universes remain in the cosmic background radiation or the large-scale structure of the universe. Some researchers are attempting to interpret abnormal energy distributions in the early universe as traces left behind by a previous universe. However, no definitive proof has been found to date. Still, one of the most exciting ideas about the origin of our universe is that our universe does not have a unique beginning, but is merely a part of an infinite cycle. Even if we cannot know for certain whether there was another universe before the Big Bang, this question prompts the human mind to question the beginning of the beginning. If another universe really exists, it would be a transformation so great that it would fundamentally shake our concepts of time, space, and reality. Perhaps one day, our observations and mathematical models will lead us to traces of that ancient universe. Or perhaps humanity will never find a definitive answer. 3. Do cosmic cycles cause universes to be born and die infinitely? The theory of cyclical universes is one of the oldest philosophical and scientific ideas in human history. Since ancient times, many civilizations have believed that the universe is constantly being born and dying in a kind of cosmic breath. According to this theory, which modern science also takes seriously, our universe expands at regular intervals, then contracts again, and finally ends in a big crunch. This collapse triggers a new Big Bang, causing the universe to be reborn. These cosmic cycles symbolize both infinity and renewal. If the universe is born and dies an infinite number of times, then everything we experience has already been experienced in other universes, perhaps an infinite number of times. The real question here is whether each cycle is exactly the same, or if there are small changes each time. These changes could provide important clues about how the laws of physics, matter, and energy are shaped in each cycle of the universe. Cosmic cycle models are explored through various theories, such as the Big Crunch, Big Bounce, and ekpyrotic. The common thread among these models is the idea that the beginning and end of the universe are not separated by a clear line, but exist in a continuous flow. However, observations show that the universe is currently expanding at an accelerating rate, which calls into question the validity of cyclical models. Nevertheless, due to the unknown nature of dark energy and the future of the universe, the idea of a cyclical universe remains alive. The idea of cosmic cycles suggests that the universe does not have a true end, and that we are living in a state of constant motion. This idea elevates human existence from a mere coincidence to a meaningful part of a cosmic cycle. Perhaps the universe, like a breath, will be reborn and die again forever. We are merely witnessing a brief moment in this endless cycle. 4. Could the Big Bang have been the result of a big crunch? The idea that the Big Bang may have been born from the big crunch of a previously existing universe is one of the most debated scenarios in modern cosmology. According to this model, our universe was once extremely large, vast, and old. Over time, it began to collapse under the influence of gravity. All matter and energy gathered at a single point, and eventually this compression reached an unbearable point. It was at this exact moment that the Big Bang occurred, and a new universe, new physical laws, and a new flow of time began. This scenario suggests that the beginning of the universe is actually an end, meaning that the end of a previous universe leads to the beginning of a new one. The Big Bang arising from the Big Crunch forms the foundation of cosmic cycle theories and offers a mechanism that could serve as both the beginning and the end of the universe. In this model, the death of the universe is never a true annihilation. Rather, it is the spark of a new creation. The strongest support for the idea of the Big Crunch is the cosmic law of balance. When the density and energy of the universe reach a certain point, it begins to collapse inward. The key question here is what physical mechanisms cause the universe's contraction to lead to another explosion. Factors such as quantum gravity, critical density, and energy levels still hold many unresolved mysteries regarding how this transition might occur. If the Big Bang was indeed the result of a big crunch, then everything we experience in this universe is the legacy of a previous universe that once existed and came to an end. Such a thought invites us to reconsider the continuity and infinity of the universe. Furthermore, in this infinite cycle, each new universe may have its own unique characteristics, and perhaps one day it will be possible to discover traces of previous universes. 5. What were the laws of physics before the Big Bang? The question of what the laws of physics were like before the Big Bang is a mystery that transcends the limits of our current scientific understanding. The mathematical equations that explain the formation of the universe are generally valid up to the moment of the Big Bang. Before that moment, everything we know seems to collapse. Modern physics, particularly general relativity and quantum mechanics, become incompatible with each other in the first moments of the universe. Before Planck time, i.e., in an unimaginably small fraction of a second, 10 to the power of -43 seconds, we believe that the laws of physics as we know them today lose their meaning. Many theories suggest that the universe may have been governed by entirely different physical rules before the Big Bang. For example, according to the variable constants hypothesis, the physical constants of the universe, such as the speed of light, the gravitational constant, and the Planck constant, may have had completely different values at the beginning of the universe. This implies that the universe may have functioned in a completely different way during that period. Some theories claim that a timeless or spaceless reality prevailed in the universe before the Big Bang. In such an environment, the laws of physics as we know them may not apply. Some quantum gravity theories argue that space and time did not exist in the classical sense at the beginning of the universe, and that the laws of physics operated differently. For example, the cyclic quantum gravity theory predicts that the universe is composed of atomic structures at the Planck scale, and that the known forms of physical laws don't exist at this level. Therefore, the question of what were the physical laws like before the Big Bang actually encompasses the question of did physics even exist? In conclusion, the nature of physical laws before the Big Bang remains a mystery to scientists. Perhaps chaos reigned in the universe at that time, or perhaps other rules, unimaginable to us today, were in effect. As human intellect and technology advance, we may come closer to answering this great question. However, for now, the physics that existed before the Big Bang remains the most sought-after answer, yet the most elusive secret of humanity. 6. Could the Big Bang be the beginning of a simulation? The idea that our universe could be a computer simulation has been widely discussed in both popular culture and the scientific community in recent years. In particular, the simulation hypothesis offers a perspective that equates the beginning of the universe with the launch of a computer program. In this theory, the Big Bang could represent the moment the start button was pressed, and all the physical laws we observe in the universe could actually be the rules governing the simulation. This hypothesis has begun to be taken more seriously with the rapid advancement of technology. Even today, we can create virtual environments on our computers that closely resemble the real world. If we can create our own miniature universes, why is it impossible for a much more advanced civilization to have simulated a universe similar to ours? The Big Bang could be the moment when time was reset and the universe began to be loaded as data in such a simulation. From a scientific perspective, there is no direct evidence for the simulation hypothesis. However, some physicists suggest that certain limitations, or pixelation, observed in the structure of the universe could be traces of a simulation. The discrete nature of the space-time fabric at the smallest scale, the invariance of physical constants, and randomness at the quantum level are, according to some, clues that the universe is simulated. If the Big Bang was indeed the beginning of a simulation, we would need to completely redefine our concept of reality. Our existence could be nothing more than the operation of an algorithm, and all physical processes in the universe could be functioning like a type of program code. This question has the potential to shake the very foundations of not only cosmology, but also philosophy, science, and even human existence. 7. Are the questions why and how meaningful in the birth of the universe? The human mind is always inclined to ask why and how. These two words about the origin of existence are the foundation of all science and philosophy. However, are these questions truly meaningful in the birth of the universe? Or are they an illusion stemming from our limited perspective? Scientists constantly seek answers to the question how when trying to explain the birth of the universe. How did energy come into existence? How did time begin? How did the laws of physics come into being? However, the question why generally seeks traces of a universal purpose, a deliberate plan, and this pushes the limits of scientific explanations. Some philosophers argue that the question why has no meaning in the birth of the universe. This is because the question why presupposes the existence of a purpose, an intention, or a higher will. However, cosmology is, by its very nature, the result of purposeless processes. There does not have to be a specific reason for the existence of the universe. Here, the question how comes to the fore. That is, through what processes did the universe come into being? What physical mechanisms came into play? What conditions were met? Nevertheless, human psychology compels us to seek a cause for every event. The question, why does the universe exist, may never find a complete answer in a philosophical sense. Science can only answer the how question. It can investigate the stages the universe went through and how physical processes work. However, the why question often shifts into the realm of metaphysics and cannot go beyond speculation. In conclusion, the meaning of the questions why and how in the origin of the universe changes depending on the perspective from which we look at it. Science is content with how, while the human mind seeks satisfaction in why. Perhaps understanding the origin of the universe lies in correctly identifying the limits and meanings of these two questions. 8. Were the laws of thermodynamics valid before the Big Bang? The laws of thermodynamics are one of the cornerstones of all physical processes in the universe. Principles such as the conservation of energy and the increase of entropy play a critical role in our understanding of how the universe works. But are these laws unique to the universe as it is today, or were they valid before the Big Bang? This question has sparked significant debate in the scientific community. This is because the laws of thermodynamics are based on the assumption that time has a direction in the universe. That is, it flows from the past to the future. Since we do not know how time and space functioned before the Big Bang, it is impossible to say with certainty whether the laws of thermodynamics were valid. If time did not exist during that period, neither would entropy, and the concept of energy conservation would lose its meaning. However, some cyclical universe models suggest that physical processes were still occurring before the Big Bang, meaning that the laws of thermodynamics could have been valid during that time. Perhaps entropy resets to zero in each cycle, and the universe regenerates itself. Nevertheless, since the beginning of the universe is defined as a singularity, it is thought that the laws of physics, especially thermodynamics, lose their meaning here. At a certain point, all energy and matter are concentrated at infinite density, making it impossible for classical thermodynamic equations to apply. Therefore, We need new theories, such as quantum gravity, to say with certainty whether the laws of thermodynamics were valid before the Big Bang. Ultimately, although the laws of thermodynamics are fundamental to the order we observe in the universe today, we can only speculate about the conditions of the universe before the Big Bang. Perhaps there was a completely different thermodynamic reality at that time, or perhaps our current laws emerged with the expansion of the universe. The answer to this question leads us to question not only the beginning of the universe, but also the universality of physical laws. 9. Why can't we see the past of the universe? Looking into the past of the universe is like traveling back in time. However, this journey never goes back infinitely. Cosmic microwave background radiation is the oldest light we can observe, dating back approximately 13.8 billion years. However, we can never directly observe beyond this limit, i.e., the moment of the Big Bang and before. The fundamental reason for this is that there was no environment in the early universe that allowed light to propagate freely. In the first moments, the universe was extremely hot and dense. Photons constantly collided with free electrons, so light was trapped. The first moment when light could move freely began with the phase known as the recombination era. Before that, the universe was shrouded in a thick cosmic fog. This cosmic fog shrouds the early universe like a curtain, and no telescope or observatory we use today can see directly behind this curtain. Therefore, to observe what came before the Big Bang, we are left with only mathematical models, theories, and indirect clues. Quantum fluctuations, small temperature fluctuations in the cosmic background radiation, or irregularities in the large-scale structure of the universe provide us with clues only as indirect traces. Another obstacle is the limits of physical laws. As we approach the Big Bang, that is, as we go back to times when the universe was hotter and denser, our current physical theories become inadequate. In particular, the first 10 to the power of minus 43 seconds after the formation of the universe, known as Planck time, is an unknown region where today's physical laws do not apply. We have no observational data to understand this period, and our current theoretical tools are also inadequate. We are, as it were, on the edge of a mathematical precipice. Another reason we cannot see the past of the universe is related to the expansion of the universe and the beginning of time itself. If time and space began with the Big Bang, then there may be no physical meaning to the concept of before. Perhaps cosmic history only began to be written from this point onward, and what came before remains forever hidden. Therefore, our inability to see the universe's past may not be merely a technological limitation, but perhaps a fundamental property of reality. 10. Could the birth of the universe be a cosmic reset? Some cosmological theories treat the birth of the universe as a kind of cosmic reset. According to this view, the beginning of our universe may be a moment when the accumulation of an infinite past was erased and everything started over. This is particularly evident in models of a cyclical universe, or the Big Bounce theory, where each universe expands for a period of time before collapsing, only to be reborn through a new explosion. In this cycle, each explosion acts like a reset button, erasing everything that happened in the past. Physical laws, energy, and the distribution of matter are reshaped from scratch each time. The idea of cosmic reset raises intriguing questions about the fate of entropy and information. If all information is completely erased in each cycle, no traces of the universe's past cycles can reach the present. However, some theories suggest that small traces, or cosmic memory fragments, may persist between cycles. These traces could appear as small anomalies in cosmic background radiation, or in the large-scale structure of the universe. Cosmic reset is also very powerful in a philosophical sense. as it implies that there is no ultimate cause for existence and that the universe is constantly being reborn by chance. Perhaps the order we observe in our universe today emerged by chance after countless chaotic cycles in the past. Each new beginning could take shape under different conditions, with different physical laws, and perhaps even a completely different level of consciousness. The most striking question in this model is everything really resetting, or are there some persistent elements from the past that we cannot see? Perhaps cosmic reset is not absolute cleansing. Rather, it is a new beginning, filled with echoes of old universes hidden in the depths of the universe. Science continues to search for such traces, and perhaps one day we will truly discover faint traces of our universe's past cycles. 11. Did space exist before the Big Bang? The question of whether space existed before the Big Bang is one of the cornerstones of cosmology. According to most classical theories, space and time emerged with the Big Bang. Therefore, there is no before, because if there is no space, there can be no place, and thus no before. This is one of the most difficult concepts for the human mind to grasp. What lies beyond nothingness? If there is nothing, how can there be an inside of nothing? This paradox keeps the debate about the existence of space before the Big Bang alive. Some alternative theories suggest that a different kind of space may have existed before the Big Bang. For example, the inflationary bubbles theory, which suggests that our universe formed like a bubble in another higher space, accepts the existence of multiple regions of space. In this case, another space-time structure could have existed before the Big Bang, and our universe could have emerged as an anomaly within that structure. From the perspective of quantum cosmology, it is suggested that before the Big Bang, space was not a continuous entity as we know it, but existed as possibilities. Perhaps space existed at the atomic scale as uncertainties, and evolved into a classical continuous space with the Big Bang. Space itself could be considered a phenomenon that begins and ends. Ultimately, whether space existed before the Big Bang remains one of the most mysterious and perplexing questions in cosmology. If space was born with the Big Bang, then there was a moment when everything truly began. But if there was another space-time dimension before that, then perhaps reality is much more complex and multi-layered than we imagine. 12. What was the first relationship between time, matter, and space? Time, matter, and space are known as the fundamental components of the universe. However, the nature of their relationship at the moment of their first emergence remains a great mystery. Did they all come into existence at the same time during the Big Bang, or did one give rise to the other? Einstein's theory of general relativity states that space and time form an inseparable whole with matter and energy. Matter bends space-time, and space-time determines the movement of matter. But how could this relationship have worked at the very beginning of the universe, at the Planck scale? Quantum gravity theories suggest that these three elements may have been unified at the beginning. In other words, space, time, and matter may have existed as a single cosmic entity that later separated as the universe expanded. Perhaps there was no matter at the beginning of the universe. Only energy existed, which transformed into matter as the space-time fabric formed. How time began in this process remains an unresolved question. In addition, some theories suggest that space and time are a kind of quantum foam that ripples, rather than being continuous and smooth in the classical sense. This foam-like structure may have interacted with matter at the birth of the universe, transforming into the continuous fabric of space-time that we experience today. Perhaps at that initial moment, matter and energy were not entirely separate. They existed as a single unified whole. The question of the initial relationship between time, matter, and space is one of the most fundamental issues concerning the origin of the universe. If one of these came into existence before the others, we would need to find entirely different answers to the question of how the universe began. But if they all emerged simultaneously in a single explosion, then the beginning of the universe would also mark the beginning of all reality. 13. Was the Big Bang a black hole in another universe? According to some groundbreaking cosmological hypotheses, what we call the Big Bang may have been born from a massive black hole in another universe. This theory accepts the existence of a singularity at the center of black holes, meaning a point where matter and energy are concentrated at infinite density. If the singularity of black holes can form the seed of a new universe on its own, then our universe may have been born from the matter that collapsed into another universe. Thus, each black hole creates a new universe, and a cosmic family tree emerges between universes. This model is discussed in depth in black hole cosmology and white hole theories. Matter falling into a black hole disappears in our universe, but it may cause a brand new cosmos to expand in another dimension or universe. The idea that the Big Bang occurred inside a black hole allows us to imagine a parallel reality where time and space flow differently from an outside perspective, with different physical constants emerging. From this perspective, the birth of our universe could be just a small part of a larger cosmic structure. This theory allows us to think of interuniversal relationships as if they were matryoshka dolls. Each universe forms within another, born from the collapse of a star in that universe. This creates an infinite cycle or network of interconnected universes. Each Big Bang is actually the echo of another universe's death and contains infinite new possibilities within itself. Perhaps the black holes in our universe are opening doors to other cosmoses. Although such a model seems impossible to verify at present, as research into the nature of black holes and the origin of our universe progresses, we may one day discover that the cosmos is indeed a multi-layered and interconnected structure. This idea suggests that every death in the universe could actually be a birth elsewhere, and that existence never truly ends. The idea that the Big Bang originated from a black hole brings to mind a cosmic cycle that erases the distinction between beginning and end. What are the most interesting hypotheses explaining the birth of the universe? Countless hypotheses have been put forward to explain the birth of the universe. Some are based on classical physics, while others are so bold and surprising that they border on science fiction. The inflation theory suggests that immediately after the Big Bang, the universe expanded at an immense speed and laid the foundation for its current structure. Cyclical universe models, on the other hand, argue that the universe has been born and died multiple times, with each collapse followed by a new explosion. These are among the most widely accepted theories in the scientific community. However, beyond this, there are extraordinary ideas such as the multiverse theory. According to this model, our universe is just a single bubble, and there may be countless other bubble universes in a larger, cosmic ocean. Different physical laws and different initial conditions may apply in each bubble. This attempts to explain that existence is not unique in an absolute sense, and why we live in this universe. Quantum cosmology explains the origin of the universe in terms of probabilities and uncertainties. The Big Bang may have been a probability selection, resulting from the collapse of a quantum fluctuation. Approaches that say, the Big Bang did not actually happen, only one of infinite possibilities occurred, open the door to profound questions about the very nature of reality. Simulation theory, on the other hand, questions the meaning of existence by claiming that our universe could be a computer program run by an advanced civilization. All these hypotheses show how rich and boundless the field of cosmology is. Every new observation and every new mathematical discovery raises completely different questions about the beginning of the universe. There is no definitive answer yet, but humanity's endless curiosity seems determined to solve this mystery. Perhaps the beginning of the universe is too complex and multi-layered for us to ever fully understand. What is the origin of cosmic inflation? The theory of cosmic inflation is a revolutionary idea in understanding the origin of the universe. According to this theory, in the first moments immediately following the Big Bang, the universe expanded at an unimaginable speed. In less than a billionth of a second, its size expanded by trillions of times, laying the structural foundations of the universe as we know it today. The source of this immense expansion is sought in a special form of energy known as the inflation field. However, the true nature and origin of this field remain a mystery. Theories about the origin of inflation generally draw on quantum field theory and high-energy physics. Some propose that inflation was triggered by the sudden release of vacuum energy at the beginning of the universe. Other approaches suggest that inflation is the result of a quantum fluctuation, and the universe's newborn fabric took shape during this massive expansion. In both cases, cosmic inflation explains why the universe appears so smooth and homogeneous, the distribution of galaxy clusters, and temperature fluctuations in the cosmic microwave background. However, how inflation began, what triggered it, and why it ended remains unknown. Scientists are investigating whether there was a pre-inflation cause for this rapid expansion. Perhaps cosmic inflation is a bounce effect from the energy left over from the collapse of an earlier universe. Or our universe began with inflation as a result of an extraordinary event among multiple universes. These questions are among the greatest challenges facing cosmology. Understanding the origin of cosmic inflation will determine not only the past of the universe, but also its future. If we can fully understand the mechanism behind inflation, we may be able to understand whether our universe is truly unique, whether other universes exist, and the most fundamental rules of cosmic reality. For now, cosmic inflation remains an unsolved cosmic puzzle. 16. What was entropy like at the beginning of the universe? Entropy, the measure of disorder and randomness, plays a critical role in the evolution of the universe. Today, we know that entropy constantly increases according to the second law of thermodynamics. That is, the universe becomes more disordered and random over time. But what was entropy like at the beginning of the universe, at the moment of the Big Bang? Contrary to expectations, entropy was very low at the birth of the universe. This indicates that the universe began in an extraordinarily orderly and homogeneous state. Immediately after the Big Bang, there was incredible heat and density in the universe. However, despite such extreme conditions, the fact that entropy was so low remains a great mystery to cosmologists. This is because low entropy indicates that the universe had a very specific beginning. How this order arose is one of the most fundamental questions in cosmology and has important implications for the evolution of the universe. A low entropy beginning also laid the foundation for the structural order of the universe as we know it today. Galaxies, stars, planets, and life formed thanks to the extraordinary order of these initial conditions. If the universe had started with high entropy, large-scale structures would not have emerged, and the universe would have quickly turned into a dead chaos. Therefore, low entropy was an absolute prerequisite for the universe's current state. Why entropy was so low at the beginning of the universe remains an unsolved mystery. Perhaps the universe began with such order due to a special condition left over from a previous cycle, or through an unknown physical mechanism. Scientists continue to search for clues to this question in cosmic background radiation, or the large-scale structure of the universe. Perhaps we need to delve deeper into the mystery of entropy to unlock the secrets of the universe. 17. How was energy stored before the Big Bang? The immense energy that emerged at the beginning of the universe was the fundamental source that created all the galaxies, stars, and planets we see today. But where was this energy before the Big Bang, and how was it stored? According to the laws of classical physics, energy cannot be created from nothing or destroyed. It only changes form. However, if time and space did not exist before the Big Bang, energy could not exist in its current form. Therefore, scientists believe that energy existed in a form that did not adhere to the rules of classical physics, such as potential energy or vacuum energy. In quantum physics, it is assumed that a vacuum fluctuation, or zero-point energy, existed before the birth of the universe. This means that even when the universe did not yet exist, absolute emptiness could still be filled with energy. According to some theories, it was precisely this vacuum energy that triggered the sudden imbalance that led to the emergence of our universe. In other words, the universe may have been born from energy-filled nothingness through a massive burst of energy. Another interesting approach is the idea that energy is constantly transferred from one universe to another in a cosmic cycle. In cyclical universe models, with the collapse of each universe, matter and energy are compressed, reaching a black hole like singularity, and then transition to another universe with a new explosion. In this process, energy never disappears. It merely changes form and location. Perhaps the energy of our universe is an inheritance from a previous cycle of an infinite loop. The question of how energy was stored before the Big Bang remains a mystery, both physically and philosophically. Perhaps this energy existed in a potential reality that we cannot perceive. Or perhaps the concept of energy as we know it today was a much more fundamental form of existence that did not fit the conditions of that moment. Until science solves this mystery, energy will remain one of the most mysterious and fundamental components of existence. 18. What was the first cause that started the Big Bang? The question of the first cause that started the existence of the universe is one of the greatest conundrums of both science and philosophy. Every cause and effect chain ultimately requires a starting point. However, what this starting point is remains a profound mystery that is beyond the grasp of the human mind. There are different theories about what triggered the Big Bang. Some scientists argue that this first cause was a spontaneous quantum fluctuation. In other words, the universe came into existence suddenly as a result of a completely causeless and random quantum event. Another perspective is the idea of a cosmic cycle. According to this view, the universe as we know it today was formed after the collapse of a previous universe, and the first cause is always related to the end of a previous universe. In other words, there is no absolute beginning in the universe. Every new universe is born from a previous one. However, this approach also fails to answer what the first principle is when we go back to the very beginning of the chain. What determines what exists and what does not in a first moment where there is no time or space? Another hypothesis is the necessity of physical laws. Some physicists argue that the existence of the universe is an inevitable consequence. That is, existence is necessary as a result of physical laws. In this case, there is no specific cause that triggered the Big Bang. The universe emerged necessarily. Beyond this, some metaphysical approaches propose the idea of a primordial consciousness or cosmic mind, but such ideas remain outside the realm of scientific explanation. In conclusion, the question of what was the first cause that initiated the Big Bang lies at the very heart of humanity's quest for meaning. Although approaching this question through scientific methods is becoming increasingly difficult, perhaps one day we will achieve a clearer understanding of the origin of the universe. Until then, the first cause will remain the greatest mystery that keeps humanity's infinite curiosity alive. 19. When did the fabric of space-time come into existence? The fabric of space-time is the most fundamental structure of the universe, and, along with Einstein's theory of general relativity, is accepted as the cornerstone of physical reality. However, when and how this fabric came into existence is one of the most mysterious aspects of the Big Bang. According to most cosmological theories, the fabric of space-time began to exist at the moment of the Big Bang. In other words, there is no before, because if there is no space-time, there is no place or time for anything to exist. Quantum gravity theories, on the other hand, suggest that space-time may be much more complex than a classical fabric, resembling a quantum foam. From this perspective, space-time initially existed as a constantly fluctuating and changing network at the atomic scale. As the universe expanded and cooled, this network began to resemble a smooth fabric in the classical sense. In other words, the fabric of space-time took on its current form as the universe expanded. According to some theories, the fabric of space-time underwent a phase transition at the birth of the universe. Just like water turning into ice, space-time, which behaved differently at very high energy densities, suddenly acquired its current fluid and flexible structure. During this process, physical constants were also shaped, and with the expansion of the universe, time and space began to exist, intertwined with each other. Fully understanding when and how the fabric of space-time formed would unlock some of the greatest mysteries of the universe, including its origins and even the period before the Big Bang. New quantum gravity theories, clues from the cosmic microwave background, and mathematical models are opening exciting new avenues for science. Nevertheless, the true origin of space-time remains one of the greatest and perhaps most complex questions in modern physics. 20. Was the Big Bang a vacuum fluctuation? According to some contemporary theories, the Big Bang may have been the result of a sudden fluctuation in the cosmic vacuum. Even when thought of as absolute emptiness, the vacuum is filled with energy, according to quantum field theory. This energy is called vacuum energy, and under certain conditions, it can lead to a sudden imbalance that results in a massive energy explosion. The Big Bang may have been the result of such a vacuum fluctuation, causing the universe to fill with immense energy from nothing. This idea is particularly known as the transition from false vacuum to true vacuum scenario. Here, it is assumed that at the beginning of the universe, energy was in an unstable state and suddenly transitioned to a lower energy, more stable state. The immense energy released during this transition triggers the expansion of spacetime and leads to the formation of matter and radiation. This process is like flipping a cosmic switch, initiating the entire universe simultaneously. The vacuum oscillation theory may also explain why the universe began so uniformly and why the cosmic background radiation has a nearly homogeneous temperature. This is because the entire universe was born at the same time and under the same conditions. However, this model still leaves unanswered questions about the origin of vacuum energy and why such an oscillation occurred. Additionally, what existed before such a vacuum oscillation remains a great mystery. Whether the Big Bang was a vacuum oscillation continues to be investigated both theoretically and observationally. With the advancement of quantum field theory and cosmological observations, this mystery may be unraveled. Until then, vacuum fluctuations will remain one of the most intriguing and mysterious explanations for the origin of the universe in cosmology. 21. What was the role of quantum fluctuations? At the moment of the universe's birth, quantum fluctuations represent one of the most mysterious and striking mechanisms in cosmology. According to quantum physics, even absolute emptiness is not completely static. Energy fluctuations occur continuously. In the first moments of the universe, these fluctuations, which occurred at the Planck scale, played a decisive role in the formation of today's galaxy clusters, stars, and planets. In other words, the smallest randomness in the universe became the building blocks that shaped the largest structures billions of years later. The reason quantum fluctuations are so critical is that during the inflationary phase of the universe, these small fluctuations were magnified on a cosmic scale. A tiny energy difference spread across vast regions of space-time during inflation, creating the first density differences in the universe. These differences eventually led to the accumulation of matter, which in turn gave rise to the formation of galaxies and stars. In other words, all the large-scale structures in the universe are actually the result of microscopic quantum fluctuations that occurred at the very beginning. This process can also be observed in the cosmic microwave background radiation. Today, when we look at any point in the sky, we can observe these small temperature fluctuations that formed billions of years ago. The traces of quantum fluctuations are like a cosmic fingerprint from the universe's infancy. These traces explain why the universe is so homogeneous, yet why some regions contain concentrated matter. In conclusion, quantum fluctuations are the most fundamental creative mechanism of the universe. They enable us to understand how order emerged from randomness and structure from chaos in the universe. The galaxies, stars, and even life itself that we have today may owe their existence to these microscopic randomnesses at the moment of the universe's birth. The role of quantum fluctuations continues to hold its place as one of the greatest mysteries behind the Big Bang in cosmology. 22. How was the transition from nothingness to existence possible? The transition from nothingness to existence is one of the most fundamental questions that science and philosophy have been trying to answer for centuries. According to classical understanding, nothing can come from nothing. However, the birth of the universe presents us with precisely this paradox. Quantum physics shows that even absolute nothingness can actually be filled with energy. In other words, even in a vacuum where nothing exists, matter and energy can emerge instantaneously through quantum fluctuations. Such a quantum leap may have occurred at the birth of the universe. Mechanisms such as quantum tunneling or vacuum fluctuation come to the fore in this process. The universe may have been born from an energy fluctuation that suddenly occurred in absolute emptiness. At this point, we are dealing with an event that is completely random and unpredictable, beyond the laws of classical physics. The transition from nothingness to existence can be likened to a leap in the sea of possibilities at the quantum level. In other words, existence is not an absolute necessity. It may also be the product of a cosmic coincidence. This idea also leads to great philosophical debate. Did existence emerge spontaneously, or was there another principle that made existence necessary? Some philosophers argue that nothingness is an unstable state, and that the emergence of something is inevitable. Others, however, claim that the concept of nothingness is not possible in the sense we understand it, and that reality is always filled with something. How the transition from nothingness to existence is possible remains one of the deepest mysteries of the origin of the universe. Science is developing more detailed models every day, but there is still no definitive answer. Perhaps the birth of our universe was the result of quantum uncertainties at the most fundamental level of reality. Or perhaps there is a much deeper physical mechanism behind this process that we have not yet discovered. 23. Was time infinite before the Big Bang? The question of whether time was infinite before the Big Bang is a fundamental issue that will determine whether the universe truly has a beginning. According to classical cosmology, time emerged with the Big Bang, and there is no before. In other words, time has a beginning, and the concept of time is meaningless before that starting point. However, in some cyclical universe models, time can extend infinitely into the past. Each universe is born from the previous one, and this chain continues infinitely backward. If time is truly infinite, the universe has no absolute beginning, and existence becomes a continuous process. In this case, every moment causes the next. The concepts of beginning and end lose their meaning. In cyclical models, or the multiverse hypothesis, the birth of our universe is seen as merely a brief snapshot in this infinite flow of time. In other words, the Big Bang is not an end, but the continuation of another universe, or the beginning of a new cycle. On the other hand, the fact that time began with the Big Bang indicates that existence has a real beginning. This view is close to the concept of creation in both scientific and philosophical terms. If time has a beginning, then nothing existed before it, and the entire history of the universe began at that moment. However, the view that time is infinite accepts that there may be infinite possibilities and infinite cycles in the past and future of the universe. There is no definitive answer to this question yet. The nature of time is a subject that challenges the limits of the human mind and remains one of the greatest mysteries of cosmology. Perhaps one day, we will arrive at theories that will solve the true structure of cosmic time. Until then, the infinity or beginning of time will remain a cosmic mystery. What was the structure of space before the Big Bang? The structure of space before the Big Bang may have been completely different from our current concept of space. According to the classical view, space and time emerged together with the Big Bang. There was no before. However, some modern theories suggest that a different space-time fabric or an entirely different cosmic environment existed before the Big Bang. This environment could be very different from the three-dimensional space we know, perhaps containing more dimensions. Quantum gravity theory suggests that before the Big Bang, space was filled with tiny structures that fluctuated, constantly forming and disappearing, like a quantum foam. In this case, space itself would exist in a discontinuous and constantly changing environment. Some theories suggest that during this period, space may have had a fractal structure, meaning it was filled with a pattern that repeats itself at every scale. This is fundamentally different from our current concept of continuous and smooth space. Another approach suggests that before the Big Bang, space was completely curved, dense, and compressed. In other words, space was folded at a single point and took on the most concentrated form of potential energy. With the Big Bang, this compression suddenly expanded, giving rise to the vast and sparse fabric of space-time we know today. This process can be likened to a bowstring being suddenly released after being stretched. The structure of space before the Big Bang is one of the most challenging questions in both theoretical physics and cosmology. Our current observations can only reach the universe after the Big Bang. What came before can only be predicted through mathematical models and new theories. In the future, when quantum gravity and cosmology are combined, we may be one step closer to understanding the true origin and nature of space. 25. Is the Big Bang an illusion? One of the most radical and provocative ideas about the origin of the universe is that the Big Bang may actually be an illusion. This view suggests that the event we accept as the beginning of the universe is a product of our limited perception and the mathematical models we use. In other words, the true nature and origin of the universe may be far more complex than what we can observe or imagine. The Big Bang may simply be a narrative we have created to make sense of our cosmic past. This perspective is particularly evident in simulation theory, the holographic universe model, and some information-based approaches to physics. According to the holographic principle, the three-dimensional structure of the universe may actually be a reflection of a more fundamental, two-dimensional information surface. In other words, everything we experience in the universe could be a reflection of information encoded at a deeper level. In this case, the event we call the Big Bang would actually be the virtual beginning of another reality. Furthermore, the limited capacity of mathematics to fully describe the universe suggests that our cosmological models can only partially capture reality. All observations regarding the beginning of the universe are valid only in the reality that we can perceive. However, there may be completely different, perhaps incomprehensible processes at work at the foundation of the universe. In this case, the Big Bang and the entire history of the universe would be nothing more than an illusion, like mistaking a shadow for reality. The answer to this question poses a challenge that tests the limits of scientific progress and human intellect. If the Big Bang is an illusion, we need completely new ways of thinking and radical scientific revolutions to understand the true nature of the universe. All we know at present is that the Big Bang model is the explanation that best fits our observations, but the possibility remains that the true reality lies far beyond our current knowledge. 26. How was information stored at the birth of the universe? The concept of information is not only decisive in biology or society, but also in the most fundamental structure of the universe. In modern physics, the past and future of a system are directly related to the information stored in that system. So, at the moment of the Big Bang, how was information stored? According to quantum physics, no information is ever completely lost. Every interaction, every fluctuation, behaves like a code that determines the future structure of the universe. Thus, even the smallest fluctuations that occurred in the first moments of the universe played a role in the formation of today's stars, galaxies, and even chemical elements. In the early universe, information was mostly hidden in the form of energy distribution and quantum fluctuations. We can still read the information from those first moments in the cosmic microwave background radiation. However, the information at the birth of the universe did not exist in the classical sense of a database, but in a much more complex and wave function-filled form. Superpositions of quantum states and probability waves were forms of storage and transmission of this information. As in the example of black holes, the information paradox may also apply to the universe as a whole. If information never completely disappears, then all the microscopic states that arose at the birth of the universe must leave some kind of trace in our present-day macroscopic structures. Every photon, every quantum particle is a carrier of events that have occurred in the history of the universe. As the universe expands, this information transforms into more complex forms, but the basic traces are always preserved. Ultimately, understanding how information was stored at the birth of the universe allows us to understand the continuity of existence and the traces of cosmic evolution. Perhaps in the future, with more advanced technologies, we will be able to read this hidden information from the first moments of the universe in greater detail and reconstruct the past from the present. Information, as the invisible skeleton of cosmic history, continues to carry the secrets of the universe. 27. Does cosmic memory remember the previous lives of the universe? The concept of cosmic memory suggests that the universe is not limited to the present, but may carry traces of past cycles and previous universes. In cyclical universe models, each explosion and collapse may transmit its own traces to future universes. These traces could be hidden in the cosmic background radiation, the distribution of galaxies, or the fundamental properties of matter. In other words, the universe carries the memories of its own past deep within its structure. One of the most important ideas supporting this is the non-destruction of information. According to quantum theory, every event that occurs in the universe leaves a trace. Nothing is ever completely forgotten. The energy fluctuations that followed the Big Bang, the formation of galaxies, and the distribution of chemical elements may carry traces inherited from previous universes. Some physicists suggest that the anomalies detected in the cosmic microwave background may be echoes from a previous universe. Cosmic memory is fascinating not only in a physical sense, but also in a philosophical sense. If the universe somehow remembers its past, cosmic history may operate like a continuous chain of memories. Each new universe partially inherits the information, structure, and potential of the universes that came before it. This chain could be the reason behind the order and recurring structures in the universe. Perhaps many cosmic events we consider coincidences are actually the result of influences from previous existences. 28. Was quantum superposition effective at the beginning of the universe? Quantum superposition is the property of a particle being in multiple states at the same time. Whether this principle was effective at the birth of the universe is one of the deepest questions in cosmology. According to some theories, at the beginning of the universe, all reality was in a state of massive quantum superposition. In other words, the how of the universe was an infinite number of possibilities superimposed on each other at the beginning. This superposition collapsed into a single reality, our universe, in a wave function collapse at the moment of the Big Bang. This perspective offers a new explanation for why the universe is the way it is. Among all possible universes, ours, with its specific physical constants and initial conditions, was selected. This selection could be entirely random or dependent on quantum-level chance. While some of the probability waves that existed at the beginning may have collapsed into observable reality during the Big Bang, others may continue to exist in other possible universes. The fact that quantum superposition was effective at the beginning also supports the multiverse theory. If countless possibilities were superimposed at the beginning of the universe, each possibility would have been realized in a different universe. Our universe would be just one of these possibilities that came to pass. Other possible universes exist as parallel realities that we will never be able to access. This idea fundamentally changes the classical single-story understanding of the origin of the universe. Perhaps reality is much broader and more layered than we know. We are merely at the realized end of a wave of possibilities. Quantum superposition continues to be debated in both cosmology and philosophy as one of the most radical and fascinating explanations for the origin of the universe. 29. Did multiple possibilities exist before the Big Bang? The idea that multiple possibilities existed before the Big Bang is one of the most intriguing hypotheses brought about by quantum physics in modern cosmology. According to quantum mechanics, nothing is certain. Everything exists in a state of superposition, where all possible outcomes are contained within a wave function. From this perspective, at the moment of the universe's birth, there may have been not just a single path to the beginning, but countless different possibilities, countless different beginnings overlapping one another. In other words, before the Big Bang, reality was a sea of possibilities. These multiple possibilities may have emerged as a single universe with the collapse of the quantum wave function. The universe we live in is the single path chosen from this sea of possibilities. Other possibilities either did not materialize and remain potential, or, according to the multiverse theory, have found their own paths in parallel universes. This shows that there was no inevitable single scenario at the beginning of the universe, but that countless different universes could have been born at the same time. The idea of multiple possibilities is also linked to the concept known as the anthropic principle. In other words, the physical constants and fundamental laws of the universe were not randomly determined in a way that allows life and consciousness to emerge, but rather, they are the result of only those universes where life is possible becoming observable out of all the possibilities. Our universe is just one of these multiple possibilities, which is why we are here and able to observe this reality. This approach adds a completely new dimension to questions about the origin of the universe. Perhaps the answer to the question why this universe is not because it could not be otherwise, but because all other possibilities exist in other universes. The multiverse hypothesis, both cosmologically and philosophically, greatly expands the boundaries of reality and suggests that the universe may not have a single destiny. 30. Could the beginning of the universe be a conscious choice? Whether there was a conscious choice at the beginning of the universe is a fascinating debate that brings together cosmology, philosophy, and metaphysics. Although science currently attributes the origin of the universe entirely to physical processes, the human mind cannot help but seek a conscious will behind such a vast and complex order. This idea extends to some religious or spiritual traditions that believe the universe was initiated by a creative force. In modern cosmology, while the concept of conscious choice remains speculative, it continues to be a subject of debate. The idea of conscious choice presents a scenario in which the physical laws and constants of the universe were not chosen by chance, but rather in a way that serves a specific purpose. Here, it is suggested that the first cause that triggered the birth of the universe may not have been entirely random or inevitable, but rather guided by a conscious being or universal intelligence. This is particularly evident in approaches that seek to explain the fine-tuning problem, why the universe is so well suited for life, through intelligent design. From a scientific perspective, however, there is currently no concrete evidence that a consciousness, or will, existed at the beginning of the universe. However, in quantum physics, the observer effect, where a system transitions to a specific state upon measurement, has led some thinkers to consider the possibility of a fundamental connection between consciousness and matter. If consciousness truly lies at the foundation of the universe, could traces of this conscious influence be present in the Big Bang and the universe's selected paths? There is no definitive answer to this debate, and it will likely continue indefinitely at the intersection of science and philosophy. Nevertheless, the question of whether there was a conscious choice at the beginning of the universe continues to shed light on one of humanity's deepest quests for meaning. Perhaps one day, we will uncover far more striking findings about the role of consciousness in the origins of reality. 31. Why does time flow forward? The emergence of direction in time at the birth of the universe, i.e., the formation of a single flow from the past to the future, remains a great mystery that has not yet been fully explained by physics and cosmology. The second law of thermodynamics states that in a closed system, entropy, or disorder, constantly increases. This increase is one of the most fundamental explanations for why time flows forward rather than backward. However, this raises the question of how and why the arrow of time was determined in this way at the birth of the universe. Since entropy was incredibly low at the moment of the Big Bang, it began to increase throughout the universe's development, creating a cosmic arrow that propels time forward. In other words, as the universe expands, a flow from order to disorder begins. This process is the physical basis for the perception of time as unidirectional. If entropy had been high at the beginning of the universe, time would not have a distinct direction as we know it today. In quantum cosmology, the direction of time is determined by the collapse of the wave function and the initial conditions of the universe. The expansion and cooling of the universe change the structures of matter and energy. And with the passage of time, everything becomes more complex and disordered. The reason why time flows forward is fundamentally due to the asymmetry in the initial conditions and the physical laws that maintain this asymmetry. The answer to this question is not only crucial for physics, but also for philosophy and discussions about consciousness. Because the direction of time shapes everything from our memories to our perception of causality. Although we do not yet fully understand why it flows forward, thanks to the conditions at the origin of the universe and the role of entropy, we can only experience time as a single flow in one direction. 32. Why was there so much matter at the birth of the universe? Why we are filled with matter at the birth of the universe? Why we did not instantly annihilate ourselves with equal amounts of antimatter is considered one of the most fundamental mysteries of cosmology. Theoretically, the Big Bang should have produced equal amounts of matter and antimatter. When these two combine, they annihilate each other, leaving only pure energy behind. However, observations show that there is a very small excess of matter over antimatter in the universe. This tiny excess is what made all the stars, galaxies, and life we see today possible. This matter-antimatter asymmetry, baryogenesis, problem requires us to delve into the processes that occurred in the first moments of the universe. Quantum mechanics and particle physics point to certain violation processes as the cause of this asymmetry. CP violation, i.e., the breaking of charge parity symmetry, created a very small imbalance during the expansion of the universe, resulting in matter being slightly more abundant than antimatter. Without this small asymmetry, nothing would exist in the universe. Cosmic inflation and the rapid expansion following the Big Bang allowed the effects of this asymmetry to spread throughout the universe. Thanks to this excess, which laid the foundation for galaxies, stars, and planets, the universe quickly attained its current complex structure. If this imbalance had not existed at the beginning, the universe would have remained an empty stage filled with light. Today, we do not know the answer to this question with certainty. However, the fact that we live in a universe filled with matter is one of the greatest miracles of existence. Scientists are trying to understand the origin of this asymmetry through particle accelerators and cosmic observations. Perhaps one day, there will be a theoretical revolution that will fully explain why the universe is filled with matter. 33. Was space-time curved before the Big Bang? The structure of space-time before the Big Bang is one of the most perplexing questions in science. According to general relativity, as matter and energy become more concentrated, the fabric of space-time bends, and when density approaches infinity at a single point, a singularity occurs. When we consider the Big Bang as a starting point, it is likely that the space-time before it was incredibly compressed, complex, and curved. Since the universe had not yet expanded, we only have theoretical predictions about what space-time might have looked like. Some quantum gravity models suggest that just before the Big Bang, space-time was twisted and tangled like a cosmic ball of yarn. It is thought that space-time had a foam-like structure at the atomic scale and did not have a smooth, classical fabric. This twisted structure may have undergone a sudden change with the expansion of the universe, resulting in its current smooth and continuous state. In other words, the cosmic beginning may mean the release of space-time from its tense and twisted state. Another interesting view is that space-time may have existed in a multi-dimensional structure before the Big Bang. String theory and some modern approaches suggests that at the beginning of the universe, extra spatial dimensions were collapsed or folded. But with expansion, some of these dimensions unfolded to form the three-dimensional space we know today. In this case, curved spacetime is not just a physical phenomenon, but also a result of the interaction of multiple dimensions. As a result, the question of whether spacetime was curved before the Big Bang is one of the most fundamental questions awaiting an answer, as it delves into the true origin of the universe and the depths of the cosmic fabric. New observations and theoretical breakthroughs in this area may open entirely new doors to understanding the reality of the universe's beginning. 34. How did the first nucleus of the universe form? The formation of the first nucleus of the universe is based on the extraordinarily complex processes that took place in the first few minutes after the Big Bang. This period is called nucleosynthesis, and it is during this process that the first light elements in the universe, hydrogen, helium, and small amounts of lithium, form their nuclei. Initially, the temperature is so high that protons and neutrons constantly transform into one another. As the universe begins to cool slightly, these particles come together to form the first atomic nuclei. Nucleosynthesis is like the chemical signature of the early universe. Approximately 3 minutes after the Big Bang, the temperature and density allowed protons and neutrons to combine stably. First, deuterium, heavy hydrogen, formed, followed by helium and lithium nuclei. The ratio of these elements can still be observed today in the cosmic microwave background radiation and in the chemical composition of stars throughout the universe. Thus, the formation of atomic nuclei in the first moments of the universe has left behind a cosmic memory that has remained unchanged throughout cosmic history. The quantity and ratio of the nuclei formed during this process are directly dependent on the expansion rate, temperature, and density of the universe. Therefore, calculations based on current observations are a crucial tool for testing the accuracy of the Big Bang model. If the ratio of the nuclei differed from theoretical expectations, the structure of the current universe would be entirely different. In other words, understanding how the first nucleus formed means solving the fundamental physical laws and initial conditions of the universe. Ultimately, the first nuclei of the universe are the oldest building blocks inherited from the Big Bang that have survived to this day. The existence of these nuclei allows us to test our models of the origin of the universe and sheds light on the earliest stages of existence. One of the most important achievements in cosmology is that we are able to explain the formation and distribution of these first nuclei with current observations. 35. What happened just before the Big Bang? What happened just before the Big Bang is one of the most speculative and least certain topics in modern cosmology. According to the classical view, the Big Bang is the point at which time and space began, and there was nothing before it. However, cyclic universe models and some quantum gravity approaches suggest that processes such as the collapse of another universe, the rise of vacuum fluctuations, or a cosmic jump may have occurred before the Big Bang. In the cyclical model, a universe contraction called the Big Crunch may have occurred before the Big Bang. During this process, the entire universe collapses back into itself, density increases, and temperature reaches unimaginable levels. Finally, in this singularity state, the limits of physical laws are exceeded, and a new universe is born with a fresh explosion. This cycle can repeat infinitely. Each cycle may bring new physical conditions and different structures. According to some quantum cosmology models, a quantum foam of reality existed immediately before the Big Bang. Space-time was composed of tiny universes that were constantly being born and dying. This microscopic cosmic foam became unstable at a certain point, leading to the explosion that gave rise to our universe. In these scenarios, the period before the Big Bang is not a void in the classical sense, but a constantly fluctuating quantum landscape filled with potentials. Ultimately, the question of what happened immediately before the Big Bang lies beyond the limits of what current science can answer. It is impossible to directly observe what came before using current observations. However, new mathematical models and future technologies may one day reveal a glimpse of this cosmic curtain. Until then, questions about what happened just before the Big Bang will continue to drive human curiosity and scientific inquiry. In the meantime, if you like my video and subscribe, that's the most effective way to support me. 36. What does before mean in a universe without time? One of the most perplexing questions about the Big Bang is, what was there before in a universe without time? Time is classically thought of as a flow that allows events to follow one another. However, if time began with the Big Bang, the concept of before loses its meaning, because for before to exist, time must exist. So, asking about what came before the Big Bang is like asking about time in a place where there is no time. This creates a paradox that the human mind is not accustomed to. In everyday life, every event has a previous moment, a cause, and a time. However, in cosmology, the idea that time could have a beginning overturns the notion of an infinite past. If time began with the Big Bang, the concept of before the universe is logically meaningless, because if there is no time, then the meaning of when something happened is lost. Philosophically, this idea also questions the limits of existence. The idea that time has a beginning brings with it the search for an absolute first cause or first mover. If time began suddenly when nothing existed, there may be no absolute cause or precedent for existence. Quantum cosmology suggests that time is a kind of byproduct that emerged alongside the expansion of the universe. Such questions are cosmic puzzles that push the boundaries of science and transcend logic and language. Perhaps humanity's greatest challenge is to imagine a reality beyond time and space, and to try to make sense of a beginning without a before. In a universe without time, the concept of before may be nothing more than infinite silence. 37. How did the physical constants emerge at the beginning of the universe? Did the physical constants, such as the speed of light, Planck's constant, the gravitational constant, and the charge of an electron, have their current values at the birth of the universe? Or were these constants determined in the first moments of the universe and then locked in? The answer to this question is critical for understanding all physical laws and the fundamental building blocks of reality. If these constants were determined randomly or by quantum fluctuations, the physics we know today could be just one of many possible outcomes. If they emerged universally and necessarily, then existence has a deep-seated order and necessity at its core. Some theories suggest that the physical constants became fixed during a phase transition in the first moments of the Big Bang. As the universe cooled and expanded, these initially variable constants locked into place when the energy density reached a certain threshold. Just like the critical temperature at which water turns into ice, the physical laws of the universe became clear and constants were established in the first microseconds of the universe. Even the smallest changes in this process could have made the universe as we know it today impossible. Other approaches suggest that different universes may have different physical constants. In multiverse models, each universe has its own constants, and we exist because we happen to be in a universe with constants that allow life to exist. In this case, the determination of physical constants is a completely random process. In another universe, the speed of light or gravity could be entirely different, and we would never experience that universe. This topic remains one of the greatest mysteries of both cosmology and fundamental physics. Understanding the origin of physical constants could help us solve why the universe is this way, and why other types of universes might be possible or impossible. Perhaps one day, we will witness a theoretical or observational revolution that could unlock this deepest mystery of our cosmic origins. 38. Was matter and energy frozen before the Big Bang? Whether matter and energy were frozen before the Big Bang is an important question for understanding the physical conditions at the beginning of the universe. In the classical sense, freezing means that something becomes immobile, stationary, and devoid of energy. However, in quantum cosmology, this concept may have a different meaning. The cosmic nothingness, or vacuum, before the Big Bang may actually have been in a state of very low energy, i.e., potentially frozen. Here, all matter and energy exist as an invisible and motionless potential. According to quantum field theory, the universe may have been in an unstable energy state called a false vacuum. In this state, all physical processes are suspended, and the concepts of time and motion completely lose their meaning. The universe is in a state of infinite stasis, waiting for an opportunity to transition to its current dynamic and energetic state through a sudden oscillation. The Big Bang is the transition resulting from the disruption of this frozen state and the spread of energy and motion throughout the universe. In other words, matter and energy did not exist in the classical sense before the Big Bang. For them to exist, time, space, and motion had to begin. Thus, the Big Bang was not merely an event that created energy and matter, but also initiated motion, change, and evolution. The transition from frozen potential to a constantly moving and changing reality is regarded as a turning point in cosmic history. The details of this transition are still not fully understood. Perhaps the awakening of our universe was a quantum leap from absolute stillness to living chaos. Current research continues to search for traces of this great transformation in the cosmic background and the fundamental structure of the universe. Whether matter and energy were frozen is perhaps one of the most radical questions about the beginning of existence. 39. Was the birth of the universe a new link in an infinite chain? The idea that our universe is a new link in an infinite chain is a frequently discussed concept in both ancient philosophy and modern cosmology. Cyclical universe models suggest that each universe is born from the death of the previous one. In other words, the Big Bang is not an absolute beginning. It is a new beginning following countless universes that have already existed. From this perspective, time and existence have no real beginning or end. Every end is the trigger for a new beginning. In cyclical models, the universe expands for a period of time, then begins to contract, and eventually ends in a massive collapse, Big Crunch. After this singularity, a new universe, a new Big Bang, emerges with a tremendous release of energy. In each cycle, physical conditions, constants, and perhaps even the laws of nature may be different. We, meanwhile, live in the last link of this infinite chain that we can observe. This idea offers a sense of cosmic continuity and vitality. There is never true annihilation in the universe. Everything transforms and reappears in new forms. Perhaps the anomalies in cosmic background radiation, or the unusual distribution of galaxies that we see today, are traces left behind from previous universes. The infinite cycle hypothesis can also be supported by concepts such as cosmic memory and information transfer. While it is currently difficult to prove this model conclusively, the idea that the birth of the universe could be a new cycle in an endless loop remains one of the most compelling scenarios that fundamentally changes humanity's view of the universe. Existing within an infinite cycle causes us to question both the meaning of existence and our cosmic destiny. 40. Where were matter and energy before the Big Bang? The question of where matter and energy were before the Big Bang requires us to go beyond the understanding of classical physics. This is because, in the classical sense, for matter and energy to exist, space and time must also exist. However, if neither space nor time existed before the Big Bang, there could not have been a place where matter and energy could exist. This is a perplexing and paradoxical question about the origin of existence. Quantum cosmology comes into play here and suggests that matter and energy can exist in a potential form without requiring a space as we understand it. Before the birth of the universe, all matter and energy may have been concentrated in a singularity, that is, in infinite density and zero volume. Or the universe may have emerged from nothingness, with matter and energy arising through a kind of quantum fluctuation. Some theories argue that before the Big Bang, all energy and matter existed as a potential in the cosmic vacuum. In other words, everything was waiting as an eventuality or energy density that had not yet come to pass. With the Big Bang, this potential became reality, and all the matter and energy we know spread out into time and space. Ultimately, the question of where matter and energy existed before the Big Bang remains a cosmic mystery, as the concept of place itself becomes meaningless. The answer to this question is key to understanding the origin of existence, the fundamental structure of reality, and the most radical transformation that occurred at the beginning of the universe. 41. Was there nothingness before the Big Bang? Whether there was nothingness before the Big Bang is one of the most complex and perplexing questions in cosmology and philosophy. The concept of nothingness is almost incomprehensible to the human mind, as it is a state that is completely outside of anything we have experienced or can imagine. Many classical cosmological models argue that time and space began with the Big Bang. In this case, since there is no before, there can be nothing but nothingness. However, is this nothingness itself a condition or a state? Can the absence of something have a reality like an existing place or time? Some contemporary physicists and philosophers argue that nothingness is not actually a reality in and of itself, but rather a potential state that lies outside our current state of existence. According to quantum field theory, absolute emptiness, or nothingness, is not actually completely empty. Even at the quantum level, energy fluctuations and virtual particle-antiparticle pairs appear and disappear in nothingness. This process, known as vacuum fluctuations, makes the concept of true nothingness impossible, because even absolute emptiness is actually filled with energy and possibilities. The nothingness that existed before the Big Bang also raises the question, why is there something rather than nothing? Why was existence preferred over nothingness? According to some theories, the existence of the universe is necessary. That is, nothingness is an unstable state, and the formation of something is inevitable. Others argue that the transition from nothingness to existence could be the result of a completely random quantum event. The instability of nothingness may have initiated reality through a quantum leap. This means that in reality, not everything is directly linked to a chain of causality. Sometimes a beginning consisting solely of possibilities is possible. However, the concept of nothingness is not limited to physical explanations. It also challenges the limits of human understanding from philosophical and metaphysical perspectives. The argument that nothing can come from nothing has been debated for thousands of years. Perhaps what we think of as nothingness is a sea of potentials in another dimension or beyond our comprehension. Modern cosmology navigates the boundaries of mathematics, physics, and philosophy in an attempt to answer this question. Ultimately, it is still impossible to say with certainty whether there was truly nothing before the Big Bang. But this question remains one of humanity's most fundamental quests regarding the meaning and origin of existence. 42. Was chaos or order dominant at the birth of the universe? The question of whether chaos or order was dominant at the birth of the universe pits two opposing poles of the fundamental structure of existence against each other. At first glance, the Big Bang may seem like an incomprehensible explosion, a chaos of energy and heat, suggesting a beginning dominated by chaos. However, cosmic microwave background radiation shows that the first moments of the universe were surprisingly homogeneous and orderly. This indicates that order was dominant at the beginning of the Big Bang. Yet within this order, there are also random and chaotic fluctuations at the microscopic level. And it is within these tiny seeds of chaos that the seeds of all the great structures of the universe, galaxies, stars, planets, are hidden. This paradoxical situation shows that chaos and order are intertwined at the origin of the universe. Chaotic fluctuations at the quantum level have led to the emergence of order at the macroscopic scale. In other words, at the birth of the universe, there was order at the cosmic scale and chaos at the microscopic scale. During the inflationary period, the rapid expansion of space allowed small quantum fluctuations to grow and form the large-scale structures we see in the universe today. Chaos was indispensable for the construction of cosmic order. Without disorder, structure and diversity could not emerge. Physics laws, especially the second law of thermodynamics, make the increase of disorder, entropy, the destiny of the universe. In other words, the universe, which was orderly at the beginning, moves toward more chaos over time. However, the universe, which began with low entropy, laid the foundation for today's orderly structures. Thanks to chaotic fluctuations, galaxies, stars, and ultimately life could emerge. Thus, the cosmic birth is a creative collaboration between order and chaos. This contrast helps us understand not only scientific, but also philosophical aspects of human existence and the nature of the cosmos. Without this unique balance between chaos and order, the universe would be a monotonous, empty, and lifeless space. Perhaps the key to true existence lies not in absolute order or absolute chaos, but in the dynamic balance between the two. The birth of the universe shows us that order can emerge from chaos, meaning from randomness, and beauty from chaos. Cosmic history is a summary of the eternal dance between these two principles. 43. Were we born as a result of the collision of parallel universes? Parallel universes and the idea of cosmic collisions are among the most striking and speculative areas of cosmology. According to the multiverse theory, our universe is just one of countless bubbles within a larger cosmic foam. These bubble universes constantly form, expand, and occasionally interact or collide with one another. In particular, certain versions of the cosmic inflation theory suggest that our universe may have emerged not from the Big Bang, but from a collision with another universe. In this hypothesis, the collision of two separate bubble universes would release an incredible amount of energy and lead to cosmic chaos, which could trigger the birth of a new universe. Traces of such a collision might be hidden in certain anomalies in the cosmic microwave background radiation, or in asymmetries in the large-scale structure of the universe. Today, some scientists are searching for traces of such a collision by looking for cold spots or unusual patterns in the cosmic background. However, no definitive evidence has been found to date, but this possibility cannot be ruled out theoretically. The collision of parallel universes also offers a new answer to the question of why our universe is the way it is. If the beginning of our universe was the result of a collision with another universe, then our physical laws, energy distribution, and cosmic constants may have been shaped by that collision. Perhaps the fine-tuning of the universe we observe today is the result of random properties that arose after a collision. This suggests that our universe may not be truly unique, and that completely different physical realities may exist in other universes. From a philosophical perspective, the idea of parallel universe collisions suggests that there may not be a single explanation for reality and its origins. Our Big Bang could be the result of the death of another universe, or the merger of two universes. Perhaps outside our universe, an infinite number of other universes continue to experience their own collisions and Big Bangs. This model stands before us as one of the most compelling and thought-provoking scenarios that challenges the boundaries of both science and imagination. 44. Was the beginning of the universe an explosion of infinite energy? The Big Bang is often defined by the concepts of infinite density and infinite energy. But do these definitions really mean infinity? Or are they just a sign that our physical models are inadequate? In classical cosmology, the first moment of the universe is described as a singularity, a state in which space-time, matter, and energy are concentrated in an infinitely dense, volumeless point. From here, the universe begins to expand, exploding, and the vast cosmos we see today emerges. This infinite energy explosion lays the foundation for all matter, stars, galaxies, and life. However, modern physics approaches this concept of infinity with a more critical eye. This is because infinity is often more of an exaggeration stemming from the limitations of our mathematical models than a physical reality. In fields such as quantum gravity and the Planck scale, it is debated whether energy and density can truly be infinite. Perhaps the energy at the beginning of the universe was very large but finite. Even though it appeared mathematically infinite, there were certain limits that physical processes had to operate within. However, the energy behind the Big Bang was so immense that it became the source of all matter, energy, and cosmic structure today. This massive energy release caused the universe to expand rapidly in a short period of time, causing its temperature and density to drop rapidly. During the cosmic inflation period, this energy spread evenly throughout space, leaving traces that we can still measure today in the cosmic microwave background radiation. So, even though we cannot directly observe the energy at the beginning of the universe, it continues to leave its mark throughout cosmic history. The question, was the beginning of the universe an infinite energy explosion, reveals the limits of our physical models. Perhaps in the future, quantum gravity and more advanced cosmological theories will go beyond the concept of infinity and reveal the true energy distribution at the first moment of the universe. For now, what we know is that the Big Bang was not only a physical Big Bang, but also a Big Bang in the intellectual and philosophical sense. All existence, space, time, and energy were shaped in that first moment, then evolved to build the cosmos we know today. This explosion, though not infinite, is large enough to keep humanity's imagination and scientific curiosity alive forever. 45. Are traces of the Big Bang still hidden in the universe today? Can we still find traces of the universe's birth 13.8 billion years ago? This question lies at the heart of both modern cosmology and humanity's endless curiosity about the past. Although we cannot directly observe the Big Bang itself, its cosmic echoes and clues are clearly visible to any scientist who looks closely at the sky. These traces are not only found in the light captured by telescopes, but also in the deepest structure of the universe, the distribution of matter, cosmic radiation, and the ratios of fundamental elements. The most prominent trace is the cosmic microwave background radiation. Discovered by chance in 1965 by Arno Penzias and Robert Wilson, this faint radiation is like an echo from the universe's infancy. This microwave radiation, which envelops all of space, was emitted during the universe's hot, dense, and opaque phase, cooling over billions of years and stretching in wavelength to become the faint radiation we observe today. The cosmic microwave background provides a photograph of the first 380,000 years of the universe. Temperature fluctuations today show only a deviation of a few 10,000ths in the sky. These tiny differences are the seeds of density that will eventually form galaxies, stars, and planets. Additionally, the ratios of light elements in the universe carry the chemical signature of the Big Bang. The amounts of hydrogen, helium, and lithium in the universe are the result of the nucleosynthesis process that occurred in the first few minutes after the Big Bang. Today, measurements taken in intergalactic gas clouds and the spectra of stars show a remarkable agreement with the ratios predicted by the Big Bang model. In other words, the chemical history of the universe serves as a confirming document of its moment of birth. Additionally, the distribution of galaxies and large-scale structures also carries echoes of this ancient past. The random quantum fluctuations that arose in the first moments of the universe were amplified during the inflationary era, sowing the seeds for today's massive galaxy clusters, voids, and superclusters. These patterns in the cosmic structure are studied through massive cosmological simulations on computers and compared with observations. Furthermore, small irregularities in the cosmic microwave background, which some researchers refer to as cold spots or anomalous traces, may be the silent echoes of collisions between ancient universes or previous cosmic cycles. In conclusion, the traces of the Big Bang are still vividly present in many areas, from cosmic radiation to the abundance of elements, from the distribution of galaxy clusters to the speed of the universe's expansion. In fact, the stars, galaxies, and the deep voids between them that we see when we look up at the night sky are all echoes of the Big Bang that have reached us today. The universe continues to hide its past between the lines. Humanity's task is to follow these traces and unravel the cosmic story. Perhaps new traces, new secrets, and echoes of the past are still waiting to be discovered in every corner of the universe. Every question we ask about the origin of the universe is, in essence, a reflection of humanity's desire to question its own existence, its limits, and its meaning. Questions such as whether the Big Bang was truly a beginning or just a new cycle in an infinite loop, how we transitioned from nothingness to existence, and how the laws of physics and time came into being are not only scientific, but also philosophical and existential challenges. Although all of our observations, theories, and mathematical models help us unlock the secrets of the universe, there is still a wall of cosmic mystery before us. Perhaps understanding the true nature of the universe will be a journey that lasts forever. However, this journey will continue to fuel humanity's imagination, expand the boundaries of science, and prompt us to find new questions with every new answer. Because the universe is an endless puzzle that reveals itself a little more with every glance, and we are all small but indispensable travelers on the path to solving this cosmic puzzle. If you enjoyed this mysterious journey, don't forget to like the video, leave a comment, and subscribe to the Liminal Science channel. Your support helps us bring the deep silence of the universe, the magic of the planets, and the boundless imagination of science to more people. Remember, the universe is not just made of stars. It is also made of the lights within the darkness, the silent whispers of space, and the questions of the curious mind. The path to truth sometimes begins not with the brilliance of a supernova, but with the whisper of a thought. Stay with us and continue to explore the unknown together.